So welcome to everyone. If you're just hopping on the line, we've got a couple great speakers here today to tell you about WaterQuest Solutions. I'll pass it over to Liz right now just to kind of welcome you to the webinar. Hope you enjoy it.
Good morning, everyone. My name is Liz, and I'm a technical sales representative for Southern British Columbia. I take care of the customers in Lower Mainland, Vancouver Island, and Southern BC. Everything from OEMs, engineering firms to large end users. So I'm here, I'll be hosting this webinar with Bruce and Jose. We're gonna have, if you guys have any questions, we're gonna leave that to the end of the presentation, but feel free to pop them in the chat, and if they're relevant to the discussion, Sam will pause the presentation and we'll get them answered. And I believe it's 10 o'clock, so we can get going. I believe many of you have joined our webinars before. Many of you may be familiar with CGIS, but for those of you who are not, CGIS, really our expertise lies in providing solutions for critical applications in very demanding industries like mining, oil and gas, marine, pulp and paper. And innovation is really our core value. And for 40 years, we've been challenging customers and end users who is using conventional and established approaches in valve and automation. And we've been challenging these applications to provide the valve that's suitable for the application instead of something that's been used many, many times before. That's why we partner with a company like WaterQuest, because they're advancing a water-based hydraulic system in North America. And it's newer technologies. And in the room with me here is Bruce and Jose, who are owners of WaterQuest, and they're really the specialists in the use of water hydraulic systems. That can go anywhere in industrial cylinders, valve actuators, pressure motors, anywhere where traditional oil hydraulic systems can be used. We can use water hydraulic systems. And today we're going to talk about some of the myths we commonly see trying to implement this technology. A lot of people are unfamiliar with this, so there's quite a lot of myths. So we'll try to debunk them today. I hope you find this presentation informative. If you have any questions, feel free to pop them in the chat, and we'll go over the myths. And we also have an example of some of the successful implementation we've done right here in Vancouver. And on this note, I'll pass it to Bruce here, who can introduce himself.
Hello, everyone. I'm Bruce Hicken from WaterQuest Solutions, obviously. This company, a little bit of background on our company. It was started by my father, Al Hicken, who used to work for Custom Gaskets for about 10 years. And in 2013, he started WaterQuest Solutions with the goal of bringing water hydraulic systems and components to the masses. I joined him in 2018, about a year before he passed away, and I've been continuing his legacy ever since. Along the way, during his dealings with Metro Vancouver, he formed a friendship with Jose Perez. And 5 years ago, after retiring from Metro Vancouver, Jose joined WaterQuest as a partner.
Hi, everyone. I'm Jose Perez. I've been doing mechanical engineering for over 50 years. I worked in Switzerland for 15 years, designing the biggest cold rolling steel machines in the world. Then I worked for the Atlanta submarines, designing the first submarine over 40 years ago, and it's still running as we speak. Then I worked for the heavy engineering in the pulp and paper industry, and worked for Metro Vancouver for over 30 years, being in charge of system improvements for 5 wastewater treatment plants. My job was mostly improving systems in the operational and mechanical department. And now, for 5 years, I've been supporting WaterQuest Solutions to making sure that we can be for the future more environmental.
So water hydraulics is often misunderstood. I'm sure a lot of people out there have ideas about it. Many think it's simply a weaker alternative to oil hydraulics. But today we're going to address these misconceptions head on. By the end, we hope to show why water can be a game changer for your hydraulic systems without sacrificing performance or reliability. So what are water hydraulics? In simple terms, they use water, just ordinary water or seawater, instead of oil to power hydraulic systems. By switching from oil to water, we can eliminate pollution risks, increase safety, and boost efficiency. What are often viewed as disadvantages in water hydraulics are really just a different set of rules that apply when using water as a hydraulic medium. Rather than limitations, water's unique properties offer advantages, such as lower viscosity, faster component movement, and a cleaner environmental footprint.
So WaterQuest Solutions is very similar to CGIS in the sense of they really focus on the solution for the application. So they do provide a turnkey solution. They can support you guys with anything from early engineering stages to supplying and commissioning the system on site. But besides the solution and turnkey solution itself, they can support you with individual components. So anything that goes into water hydraulic systems separately, like pumps, cylinders, desalination power centers, HPUs, motors, valves, air motors. They can provide them replacement service, so everything.
At WaterQuest Solutions, we specialize in making the transition to water-powered systems as seamless as possible. Our systems run on tap or seawater, and we use advanced materials like stainless steel and carbon-reinforced PEEK to ensure long-lasting, efficient performance. You're going to hear us talk quite a bit about both those two today. Why do we use carbon-reinforced PEEK? From an engineering perspective, carbon-reinforced PEEK is an ideal material for water hydraulic systems because it combines lightweight strength, resistance to corrosion, low friction, and dimensional stability under extreme conditions. It offers superior performance compared to traditional materials like metal, and particularly in applications where longevity, reliability, and efficiency are paramount.
I believe you also do this
and
duplex, right?
If there is high corrosive area, like a high content of chloride, we use also duplex material, which is the Cadillac of stainless 316L. So if there is areas where it's needed, we also provide the duplex material as well. It's more expensive, but it's meant for doing those kind of severe applications.
Yeah, like marine and all
Marine
that. Yeah.
desalination systems. In the marine, yeah, for instance, for submarines, we're also being involved with the Navy in the US. Of course, high content salt, like in the Caribbean, will be more likely to use duplex. In Canada, like in England or in Europe, some parts of Europe, the salt content is not that high, so therefore stainless steel, if it's submerged or is exposed to the salt water, then it's not as critical. The only thing is we always advise them, if they don't want to spend extra money, to flush the line at the end of the day when it's not in use.
Thank you, Jose.
We are proud to be the exclusive Canadian partner of the Water Hydraulics Company from the UK. They're a global leader in this space. They have offices in 18 countries around the world. And their systems have been installed in some of the most demanding environments, from nuclear power plants to Disney water park rides. If hydraulics can work there, they can work anywhere.
Definitely a nuclear facility.
And as you can see, Andritz is one of the largest company in terms of turbines and dams and everything else. They're using our products. Underground in England they're using it as well.
Yeah.
And Bombardier is one of the Canadian companies that are also using our technology.
Yeah, the first time I saw this, I was actually shocked to see how many people have switched to a water hydraulic applications. Yeah.
And just to let you know, shortly, two weeks ago, we've been approached also by some companies, Mercedes, maybe using also our water technology as well. But this is right now in discussions.
Yeah.
Let's start with the biggest misconception: corrosion. Water is often associated with rust and degradation, but modern advancements have completely changed the game. At WaterQuest, we use materials like stainless steel and carbon-reinforced PEEK that are highly resistant to corrosion. These materials have been specifically designed to withstand the unique properties of water, especially in harsh environments like seawater applications.
I think one of the biggest myths too, that people think oil systems don't corrode, but oil systems corrode as well, right?
That's excellent. Thank you. In my 50 years experience, I've been doing a lot of hydraulics, including underwater technology for the Atlanta submarines. We find, we weren't allowed to in the first place. The first one we put in was in the Cayman Islands 42 years ago. And the government we were told that when one drop of oil in the coral reef, we would be out of business. So 42 years ago, I've been already myself involved, ensuring that there is no leak whatsoever, and we don't use fossil fuels for the submarines. So anyhow, so condensation, when you don't operate the cylinders, a lot of people think, oh, oil is okay, but when oil sits inside the barrel, eventually the condensation will be there and will create corrosion if you don't use the right materials. So this is the thing that a lot of people don't realize, that including pneumatic cylinders. They use, there's always condensation, and they have issues with corrosion down the road.
Hey, Jose, just real quick, got a question from the audience. Pardon me. Is there a reason you don't use fiberglass reinforced plastic?
They don't make, first of all, the tolerances to machine something like that in fiberglass becomes problematic. It can't be done. It's expensive, but it's also not a recyclable material.
Okay. And then a follow-up question, actually, could you explain what is peak?
Bruce? It's a thermoplastic material.
Yeah.
And it took, when the company started in Germany and in England, developing this type of technology, lubrication was an issue because they thought, they have to make a special seals, and it took them 5 years to come up with this material that now is working in 18 different countries all over the world. And so that's the reason why they use the PEEK, because it's basically an extremely good material, very low friction coefficient, and it does a great job. And so those cylinders can go to 1 million cycles. So that's to give you a perspective.
Okay, awesome.
So, and also, like in any two points of contact, where it would be metal on metal, one is carbon reinforced PEEK and the other would be stainless steel. So there's no metal on metal contact, which makes everything slide much nicer.
Right on.
Yeah, let's make it move on to two.
It's true that water freezes, but modern systems are built to handle freezing temperatures. We've integrated technologies like heat tracing, insulation, and a food grade antifreeze, I want to say, but it's polypropylene glycol, which is a food grade additive. It can go down any drain. It's not a problem with the environment, so there's no worries about.
Just to give you perspective, with that polypropylene, they make cotton candy out of that product. Just to give you a perspective, in Germany, cotton candy. So it's not, as I said, it's not an environmental issue.
Now I'm worried to eat cotton candy.
I know. Anyway, but just.
I know you guys said it's safe, but I thought cotton candy is out of sugar.
But then you can also put heat tracing, which you do. It's funny what we talk about freezing, but in the wastewater treatment plants, we have kilometers and kilometers in the plants where we have to put insulation or heat tracing, because we've seen many pipes freezing, whether it's whatever the material goes through those pipes. So the concept, the thing about people thinking that, oh, it's going to freeze. So there is always a way of overcoming those obstacles. So they're using in Sweden, New Region, and all the other places up north. And 20 years later, they haven't complained. But you have to make sure that it doesn't, you protect the freezing temperature, especially when the media doesn't move. The media moves, it's not an issue with freezing temperatures. The problem is when it's sitting doing nothing, or when you shut it down, the system, there's two options. You have to drain it to ensure, like any other people in the world, they do that, or you put heat tracing. And heat tracing is an extra expense, but that's what you do with most pipe exposed outside. 90% of the piping in our industries usually is always in the tunnels underneath or inside buildings. But yes, there are a lot of areas where there's no option. They have to bid outside. So outside, there is always an option.
Yeah.
Okay, many assume that transitioning to water hydraulics will lead to higher costs. The reality is that while initial investment might be similar to traditional oil-based systems, water hydraulics offer long-term cost benefits. No oil spills, fewer maintenance issues, reduced downtime means significant savings over time. Oil spills can incur fines and cleanup costs, costs you avoid entirely with water hydraulic systems.
Just to give you an idea about, sometimes we think that cost, at first cost is cheaper down the road. I remember struggling with Metro, especially when we have a lot of hydrogen sulfide. And in the old days, 35 years ago, I was told by them, well, don't use that, it's way too expensive. But then they realized that the gates have to be replaced every 6-8 years. And not only the downtime costs money, maybe the process had to be stopped, confined space issues. And, interesting enough, now the consultants that work for Metro Vancouver, all the specs now is basically 316 stainless, not even aluminum, just to give you an idea of how people are changing their way of thinking. But in the old days, it's all about, why I can save a lot of money, but long-term, they never save money. And I've been in that end user where I buy them, I design them, and then I have to change it because it's just corroding too often.
Yeah, and we really see that. So when you compare oil hydraulic system with water hydraulic system, both specified as a 316 stainless steel, the cost of implementation of water hydraulic is really negligibly higher than oil. So it's almost the same.
Yes.
Yeah.
Oh, just to quickly, if I may, this is happening for the last 6-8 months. Bruce and I have been approaching governments, especially also in Canada, and we found out now that it's more and more they probably is trying to stop getting fossil fuels, especially oil. In Germany, Finland, I think Sweden as well, they're banning oil hydraulic products because there are other solutions like water that exist. And so so what's happening now in the world is supply issues. If you want to get now access to hydraulic systems, in the old days, because things used to take 2 or 3 months to get parts, now you have to wait a year to a year and a half, depending what it is. So, and the prices have gone up since after the virus, we had the COVID, it's got more than double. So now we're even more competitive, even though we have better materials. But a lot of people are not aware of it.
That's interesting. Thank you, Jose.
Water hydraulics can't handle high pressure. It's often assumed that water hydraulics can't reach the same pressures as oil-based systems. The truth is our systems can handle pressures up to 160 bar, delivering power and control comparable to oil-based systems. That's more than enough for most industrial applications, making water hydraulics a viable alternative without compromising on performance. While it's true that oil provides excellent lubrication, advances in material science have allowed water to become a suitable hydraulic medium. Carbon reinforced PEEK significantly reduces friction, ensuring that components operate smoothly even under demanding conditions.
Just to give you oil, as we all know, the friction coefficient overall can be 90 to 95%. We can go up to 90 to 95 with water, just to give you perspective.
One of the most compelling reasons to adopt water hydraulics is their environmental benefits. With water as a hydraulic fluid, there's no risk of oil contamination, no leaks to worry about, no regulatory fines to consider. It's an entirely cleaner, safer, and greener system. But there's more to it than just environmental perks. Water hydraulics also offer better energy efficiency. Unlike oil, which heats up quickly and requires cooling, water systems dissipate heat more effectively, reducing energy waste and improving overall operational consistency.
I think another thing to mention is that we did mention that everything does corrode, and at some point there is spillage of oil can happen in the oil hydraulic system, and it could become a not only environmental hazard, it could be a fire hazard as well.
Yeah, and for instance, because of the corrosion issues that we are surrounded by, the stainless steel, in my experience, we have the submarine parts in stainless electropolish that's been there for 45 years, exposed to the salt and cycles. And so my point is that let's not kid ourselves. We have to replace it maybe 3 or 4 times in the lifetime that you're using it. With oil, with water, you don't have to. And the water is there. So it spills, it doesn't do anything.
And I think disposal is a big thing too. I don't know how you guys, every time I cook something deep fry, I always wonder where I'm gonna put my oil. I know I'm not supposed to put it down the drain to clog my pipes, so I have to put it in a special jar and then go to the garbage bin. Hopefully nobody can see me there putting it into.
Yeah, also oil.
So like disposing oil system, like oil from the hydraulic system, that nasty oil, old, like viscous, and like it can cost a lot to the company, right? So
Yeah, in Metro Vancouver, we have WCP that come and inspect on a regular basis how we store the recycled oil and how we store the good oil, because it's a fire hazard as well. So it's a safety issue that a lot of people don't take it for granted. Also, oil is extremely nasty. We had concrete damage and asphalt eats it right away. So one drop of oil, not one drop, one spoon of oil will contaminate 100,000 liters. A lot of people don't have a clue. It will take about 30 years to disintegrate. It's all those things that are hidden out there that they don't have an idea what's going on. Imagine everybody spills, and when you do maintenance or you replace the oil or the line burst, which it happens so many times, including the ferries for BC ferries, all that stuff adds up into the environment, and we just don't have an idea of what's going on in the world. And I think we are paying more attention.
Were you gonna talk about the operation?
I think we briefly touched on viscosity and
Yes,
efficiencies, right?
Regarding the viscosity, water is about 3 times less viscosity than the oil. Therefore, the water can run faster through the pipes. Also, the pipes can be 1 size or 2 size smaller, because it doesn't have to be that big because there's not much restriction to there. So then you can save cost by reducing the pipes from, let's say, 1 inch to 1/2 inch or 3/8. That makes a big difference per foot when you have to replace them. And so yeah.
Also, you need less energy, right?
Yeah, it adds up to a 20% reduction in energy.
Yes,
which is pretty
so
good.
it's also energy reduction as well.
Okay, so yeah, we have a case study here for Iona water treatment facility right here in Richmond.
Yeah, can you show them the picture of the other?
Yeah.
Oh yeah, just to I designed that particular system. The reason for that is because my job, and because I had some experience with Atlanta Submarines doing improvements and maintenance and design our own systems, which we did. We didn't hire anybody. This is a system designed for the sedimentation tanks, which has 3 containments, 3 tanks to basically remove scum and sludge. It's acting like a sludge conveyor. And as you can see to the left of the electrical motor, you see the hydraulic motor with a reducer to create the torque and speed is required. So they've been running for 28 years now, or over 28 years, running 3 conveyors, 3 outputs at the same time, nonstop, 360 days. So yes, it's reliable, but you can see even the drips and the oil dripping there after 4 or 5 years. And those things eventually also corrodes, and they have to be replaced as well. So then the GBRD decided, because they're under pressure in terms of environmental issues, is asking companies, when they bid on certain applications, they said to the competitors or the vendors, they said, what have you done or for the environment for the last 5-10 years? And what they do now, the GVRD makes a metrics evaluation to evaluate not only the cost, but evaluate what you've done for the environment to reduce the footprint and the corrosion and the contamination issues that we face. Because when that oil contaminates, goes into the drains, you think the wastewater can clean it, but at a certain degree, it still gets to the effluent water, eventually to the ocean where it's contaminated. So anyhow, so the government asked, why don't you just do an example? Wainville Limited, the hydraulic company who has been doing for 50 years hydraulic systems, I helped them designing the system there to change it to water. And so this has been operating as a pilot for 5 years to show them, look at that, this is now 5 years ago, 5 years old, and it looks like you bought it yesterday. All is attached to CDEC, so it's all computerized, using pressure, VFDs and all that to control the speed and the water that goes through the HPU. So yeah, that's one example, but water has a lot of different applications, from open valves, closing valve, desalination systems, steering boats, everything. Motors for boats as well for water. We designed right now one motor, one boat with the First Nations, that instead of running with diesel engine is going to run with that motor that you see there, the blue reducer, and then the shiny part, stainless steel, is the motor. So that motor would be attached to the same idea, the reducer, and the reducer propeller. That's all. That's very simple. Running with a pump and with hydrogen fuel. So this is we're trying to design, we designed it already. We're just trying to get the money to put the first exclusive boat for the First Nations ever done to fish for them, because the First Nations are extremely concerned about all the leaks. And I'll give you an example, because I'm very close to the First Nations Musqueam in Vancouver. They said that when they go fishing and they get the fish to the deck, they already have an inspector and they see some kind of oil sitting on the fish. They have to get rid of all the fish regardless. They're not gonna go and select which one hasn't, because they run drums, steering system, all that with oil. So they all leak. And they had that where they lost thousands of dollars for not being, so they're very interested in our technology right now. So we're working with them as we speak.
That seems like a lot of wasted fish. Thank you, Jose. Yeah, so maybe we can just summarize.
Yeah, summary of benefits. The benefits of switching to water hydraulics: cleaner, safer operations with 0 oil spills, lower maintenance costs and longer equipment lifespan, high performance even in extreme conditions, and reduce environmental impact and easier compliance with regulations. Any companies trying to get certified green, there's not a cleaner fluid than water.
Yeah, considering there's ESG scores right now, it's a very big deal for a lot of companies, especially end users I'm working with. So definitely this is something that can help you lower your ESG and emission scores. So
absolutely, yeah. And if you pair it with renewable energy like solar or wind.
Can I add something quickly, if I may? I know we're talking oil versus water, and people are gonna say, for instance, oh, why don't they use pneumatics? Well, that's another thing. We've done studies on pneumatics. Not only you have the same thing with what is it called, the corrosion issues, but also using air, you need, as you know, compressors, desiccant dryers, and all that. And then what happened is the efficiency, which is funny, PC Hydro gave us a rebate for using more efficient motors, electrical motors, and they give you a rebate for that. But they don't talk about the compressors, which is a very high maintenance item. And on top of that, they're only 10 to maximum 20% efficient. I'm not sure if you hear this right. And air always leaks. So I guess if you have a lot of money and you see all the leaks and all that, usually you lose 10% while let's say the system is not running. In order to keep up, the compressor always gets to nothing because it's leaking out. And so you have all those costs that they're very inefficient. So when it comes to cost of energy, air is very expensive. Also, if you use a small size cylinder for, let's say, 1, 2, or 3 inch actuators and all that, I'm not gonna go and make a big deal out of it. But when you have tremendous forces, when you start closing and open and closing 24-inch valve, 30-inch valve, 16 valve, you start requiring about two 24-inch, 30-inch pneumatic valve. And pneumatic not only is inefficient, but it's a bomb, which a lot of people don't know that. A bomb means when you it's like a spring, you store that energy that it can explode anytime. And a lot of people don't even check if that cylinder is corroding or not because they don't do that regularly.
Also the size of the cylinder, right?
So this pneumatic is not only the space is huge. For instance, we can give you a 4-inch cylinder or 6-inch instead of a 24 or 30-inch pneumatic cylinder. So the footprint is a lot smaller, a lot cheaper down the road. And when people think pneumatic is cheap, you still have to have the compressors running it. So instead of an hydraulic HPU, it's the same idea, except the HPU is 90% efficient versus the air. Anyhow, I just want to put that for you to understand why we believe that the water is the way to go for a lot of things.
Yeah, thank you, Jose.
So if you're ready to learn more or explore how water hydraulics can enhance your operations, you can reach out to us directly, visit our website. We're here to guide you through each step of the transition to a more sustainable hydraulics solution.
Yeah,
If you need any help, for instance, to put something together, we're happy. That's what I do for a living. I've been designing systems for many, many different companies. And you just have to tell them, what is your problem? What is your issue? And then I'm more than happy. We're both more than happy to give you some solutions like CG does to you guys as well.
Yeah.
I've got a couple more questions before we sign off. The first one was, usually hydraulic systems use the lubrication of oil to protect high precision surfaces on hydraulic pumps and motors. How do water systems deal with that?
I didn't hear very well.
So could you repeat that again, Sam?
Yeah, if you still, I don't hear you. Sorry, I have a hearing.
Yeah, no worries. So usually hydraulic systems use the lubrication of oil to protect high precision surfaces on hydraulic pumps and motors. How do water systems deal with that?
The same with the material that we talked about. We have carbon peak. Like our pumps is the piston pumps, the most effective and reliable pumps in the world. And they have the same idea. The tolerance in between is within thou. Thou. We talk about precision. So what we do, if people are interested, we always recommend to put VFTs to control the flow more efficiently. And also, I'll give an example. What is the beauty about this is when you run the system, let's say at 70% capacity, and you see an internal leak through the pumps or cylinder, that shows you that it's not delivering the flow is required. Therefore, you still, instead of being in a panic and trying to change it, if you didn't have to do the regular maintenance you did, you can still crank it up, the speed to compensate for the leak that you're having. And therefore, you can still run it for God knows for maybe another year. So without an emergency, that's the beauty about our technology.
Right on. Got another question here, and apologies if this was discussed in the start of the presentation. They're a little bit late. Can water hydraulics be used in steam power plant applications such as steam admission valve hydraulics?
Well, of course, there is areas we use, for instance, for the kilns in back east, where they use our system for what happened is a friend of mine works in that industry as an engineer, and there are issues with the wood. They waste 15 to 20% of their wood by being the wood too dry. And so they use our system that's been running now for 3 years with a humongous plant that is run mist in that area, that heat. So but what we do, we put the HPU in a separate division because some of the temperatures are so high that it doesn't matter how even the oil won't even accept that. So there are issues, depending what we can do with them, But we have applications like that where it's been in use as well in those temperatures.
Okay.
We need more detail. It's like anything else. They have to tell us what is required, what are the issues, and then hopefully we can overcome those obstacles for the client.
For sure. And like Liz mentioned, we'll be following up with our contact information, so we'll connect everyone after the webinar. Couple more questions coming in. Are there any vibration issues and how do you solve them? And a follow-up to that is any type of pipe support needed to apply?
We don't have any vibration issues in our hydraulic systems.
Okay. And there's another one. Are water actuators available for process valves?
Yes.
All right, these are easy questions. Um, and I've got one more here, which I thought was an interesting question. Would the glycol not cause any harm to fish habitat, or would glycol cause harm to fish habitat?
No, you can say that. Well, hold on. We don't use the word glycol. It's not a glycol. Glycol is nasty.
Okay.
So we have to separate the glycol from polyethylene, which is a totally different product. I told you it's made out of they make cotton candy out of that. So you can drink the water. And by the way,
It doesn't harm the fish, though.
by the way, just to give a perspective, we just talked about 1 spoon of oil contaminates 100,000 liters, while water is usually a closed system, but it's gonna leak. But the leak is so minimal, so it's just a little bit of water from the tank, right? Oil is huge problem in terms of environmental, right? So we have been using that for Iona. We even though it's not needed, where they had for a couple of years, unusually they had up to minus 15 degrees, and the glycol's been there, and it's still running 3 years, 4 years later with glycol. We say glycol. I shouldn't use that word. You started it.
I didn't start it.
Freeze, and it lost. The beauty about that, if you change the filters, which is paper filter, 10 to 20 microns, we have 2 filters there in the HPU. One is when you fill it in, it goes through a filter, it's a 10 microns.
10
right?
micron, yeah.
The reason for we doing that is because the water has iron content. That iron doesn't do as much damage to the cylinders, but what the iron does, it acts like a sandpaper in the pumps, in the motors, because they turn. Therefore, start wearing it out. So it will wear out, but then it eventually not efficient. So you remove that from it, plus other wear and tear pieces that exist in the hoses, right? And everything there that it gets captured in the filters. In other words, we have inlet to make sure that water is totally clean and not contaminated. And then we have, when the pump goes back and forth in recycling mode, the recycling has another filter, which it basically remove all the particles that you don't want into our system. You do that regularly every 6 months, that water doesn't have to be replaced and it doesn't evaporate. A lot of people also ask that question, does it evaporate? No, it doesn't evaporate there.
Okay, we've got a couple more questions that just came in. What about water hammer?
We don't have water hammer.
Right, another easy one.
Those issues are so easy. Again, I'll give you an example. Once we know the speed of the flow they require, how fast they want to, we have ways of taking the cushion that, but again, that is not an issue. We can address that if the client tell us what is critical and what can happen. We can also say based on what they give us as a specification, how we can overcome those obstacles. So that's not an issue.
Okay. Are large radial piston hydraulic motors available for water systems similar to Haglund's CB400?
Well, the end result is the same. Our piston pump are our design, the design from our company, and we stick what we know is best because it's a more reliable pump. But whatever they have as a pump, we can match exactly the other pump, except ours are the catalog of the pumps.
Okay. The questions just keep coming in. One second here. Are you able to use proportional or servo valves with the water systems?
Proportional valve, but we can also design in the future servo, but we don't need a servo. If you give us the circuit, the schematics, we can do exactly the same that any other company can do, any other thing they can do.
Okay. And another one. Does the water hydraulic system require demineralized water to operate, or would regular service water be okay?
Just regular surface water.
Okay.
Don't use recycled water, right? We make sure it's not contaminated. We use from the tap, like we drink it, right?
Okay. Sounds good. Um, I don't see any more questions right now, so I'm assuming that's it. You guys did an awesome job. That was a great presentation. I want to thank you both, or all three of you, for doing that. Liz, do you want to wrap it up?
Can I
Yeah,
say thank you to all the people that been with us? I appreciate all, and I'm more than happy to, if they send us an email, working together with them, more than happy to do so.
yeah, thank you,
If they need any
everyone.
more information. Go
But
ahead,
thank you
Dave,
so
reach out.
much for taking the time. I hope it wasn't too long for them.
No, I think the timing was great. Well, thanks again, guys. We're gonna end the webinar there and enjoy the Halloween season. We'll see you at the next webinar. Cheers.
Yeah,
Yes, thank
bye.
you.